Hi everyone, welcome back. Today I would like you to share with you a physics-based furnace animation that I really enjoyed working on. The goal wasn't here to make the animation look cool, but the key challenge is to make the animation visually understandable and show how the temperature changed inside the furnace and how heat transfer between steel slabs. In this video, first I will share with you the final animation and then walk you through the full step-by-step development of the project from client script to the project composition. So let's jump into it.
Step 1. Drilling. Traditionally, building a reheat furnace model means drilling holes into steel products to insert thermocouples. This is done across multiple products and heating cycles to gather high-fidelity temperature data for model calibration. Step 2. Modeling without drilling. We've developed an approach that eliminates this waste entirely. Instead of drilling, we build a high-fidelity physics-based simulation of the reheat furnace that takes into account radiation from burners, heat loss from the walls, and heat exchange between slabs. This simulator allows us to generate the same temperature data synthetically that would otherwise require thermocouples. That data is then used to train models that can generalize across real operating conditions. However, the simulator is extremely sensitive. Even changing a single slab in the furnace alters the outcome, which means the simulator alone is not suitable as a functional model in a live manufacturing environment. Step 3. Physics-informed learning. To handle this, we use a physics-informed neural network that adapts to changing furnace conditions. We incorporate slab geometry awareness and a two-dimensional loss function that captures the true complexity of heat transfer. This allows us to predict temperature through the full cross-section of the steel, not just surface values. That level of insight gives operators a clearer understanding of how heat evolves inside their product. Step 4. Intelligent recommendations. All of this feeds into our recommendation engine, Steelix. Steelix connects furnace-level insights to plant-level decisions, enabling intelligent physics-driven orchestration. An independent IP audit has identified multiple patentable innovations across our technology.
So this is the client script. On the script, client first mentioned the differentiation between our innovation and the traditional furnace. And client add to instruction here. This animation should transition smoothly between each other like they are a part of single animation. Obviously it will be a smooth transition. Note 2, you need to time the animation with my narration. So I make the animation according to the client narration. So this is the restriction. On the first scene, you can see client show animation as step 1 drilling. So here we show the drilling. Client mention show a 3D render of steel slab being drilled along its length. So we have to show the steel slab drilling and show the slab going into the furnace and show the slab going on a furnace. Then on step 2, furnace simulator. Client mention show a 3D render of furnace. So we have to show the furnace first, highlighting the different aspect we model. Heat generation from 3 burner. So we have here 3 burners. Client demonstrate the burner, which will really help me to understand the process. So the heat come out from these 3 burners, and then heat flow inside the furnace. I have to show the heat flow, heat loss through the walls and doors, the heat loss from the walls and door. Also heat exchange between slabs in the furnace, and they are usually peeled one on top of the other with a small gap in between them, using a space to a stack of 3 slabs each. So there will be 3 slabs on one stack. The total stack will be 2. Each stack there will be 3 steel slabs. Step 3, 2D loss function. Here we have to show the physics. There is no real-time temperature system. They can only see the whole furnace temperature. On hour we can see the temperature per slab. So in the animation we are developing a physics-based furnace model to calculate slab temperature over heating period. And the final part is to show the whole plant. We have to zoom out from the furnace view and show the whole plant. So before going to the Blender, we collect all the references from online to make the animation more accurate. So let's see the storyboard. So this is the storyboard. This is the reference for the batch reheat furnace. This is the inside factory reference, how a steel slab moves inside a factory. And this is the plan view when it will be used in the step 4, where we show the full plant. And this is thermocouple, as you see on the animation. And this is the his distribution idea, where I get idea from online to show the dynamic arrow. Here you can see the animation, and this is how heat flow. And this is also another example of the steel industry. You can see here the rolling machine. Also here I need to show the cross section. For this I make a map here. So this is the reference. So we model the furnace first. From the reference we make the model. This is the front door, and this is the back door. This is steel slab. You can see the steel slab. As client say, there will be 2 stack, and on one stack there will be 3 steel slab. So these are the steel slab. And this is stand. This is the stand, and this is inside furnace. So that's it. This is the model. You can see that it's quite simple, because the goal isn't to make the animation more complex. We just need to tell the story as simple as possible. Okay, this is the topology. And then we make the factory model, where I download the factory model from one of my friend, and then I arrange all the asset here. Like I add 2 furnace here. This is a rolling machine, and this is steel slab. This is a crane. This is a crane which hold a steel slab. Then there is 2 pipe to make the factory more real. This is a water pipe, and this is another crane. So on first scene we show the steel slab drilling.
Building a reheat furnace model means drilling holes into steel products to insert thermocouple.
And a thermocouple inside the steel slab. This is the traditional way.
This is done across multiple products and heating cycles to gather high fidelity temperature data.
Then it's go inside the furnace. Yep. This is done. Then step 2, modeling without drilling, which is our innovation.
Of the reheat furnace that takes into account radiation from both.
Yep, this is the most challenging part. I show the heat through the heat burner.
Heat loss from the walls and heat exchange between slabs.
From the heat burner.
The simulator allows us to generate the same temperature data synthetically that would otherwise require thermocouples. That data is then used
Then
to
this
train
is
models
heat loss through the walls.
that can generalize across real operating conditions. However, the simulator
And this is heat exchange from slab to slab.
is extremely sensitive.
In this part, first I make all the arrow at once, but it look very cluttered. So that's why I make 3 steps here. First the heat from heat burner, then heat loss from the walls, and heat exchange through the slab to slab.
That data is
Now
then
it's look
used
more
to train
simple
models
and
that can
clean to
generalize
understand.
across real operating conditions. However, the simulator is extremely sensitive.
This is the 2D loss function. Here this is the side by side comparison. This is traditional slab and this is the real our innovation. In this our physics based furnace we can see the real time temperature, where without our physics there will be no real time temperature here. So anyone can understand what happening here. We measure the temperature from the cross section of the steel slab. This is the cross section view. On this cross section we can get the temperature from each point. Like on this part there is high temperature, in the center low, in the middle there is more low temperature, more coolest temperature.
Their product. Step 4, intelligent recommendations. All of this feeds into our recommendation engine, Steelix. Steelix connects furnace level
Then we zoom out from the furnace to show whole plant.
insight to plant level decisions, enabling intelligent
See the steel solve here.
physics-driven orchestration. An independent IP audit has identified multiple
This is the whole plant view.
paceable innovations across our technology.
And at the end, if you are working on any complex technology that really need clear visual, feel free to reach out. Thanks for watching.